Hello students, let's look at significant figures today. Say we have a scale here that can measure in centimeters and we have a line AB whose length we want to measure. So if we look at this, it is 1.1 here and this is 1.2. So it is somewhere in between. So I would look at it and say, okay, it is between 1.1 and 1.2, so it is somewhere in between, midway. So I estimate it to be at 1.15 centimeters. So now if you look at this one and this one are certain digits. These are absolutely certain. Whereas this 5 is an estimate. I'm estimating it to be somewhere in between. So this is the estimated digit. So in every measurement, we have certain figures and one estimated digit. All these put together are called significant figures. So now 1.15. So we have three significant figures, out of which two are certain and one is estimated. Let's look at another example. This was ending somewhere here. Okay, now it is more than 1.1, but it is not at 0.5. It is, so if I have to guess, I would say it is, okay, I would say it is 1.2. So now again 1 and 1, these two are certain and this is an estimated digit. So total we have three significant figures. So certain digits plus one estimated digits. These put together are called the significant figures. Okay, let us see one. Let us say the scale is like this. And here it is ending at 1. And I look at this. Okay, 1 is certain. 1 is certain and it is so close to 1, so I would say it is 1.0. So 1 is the certain digit and 0 is the estimated digit. So we have here the number of significant figures is 2. 2 significant figures. Certain and this is the estimated. If you look at this scale it was able to measure up to 1/10 of a centimeter. Whereas this one we are pretending it can measure up to 1/100th of a centimeter. And this division here is 0.99. This one is 1 centimeter mark and this one is 1.01 centimeter. And if it ends here, now my estimate it is 1.0 and another 0. This is the guess. So here we have 1.00 centimeters and this is the estimated one and these two are the certain. Here we have three significant figures. Let us say there is another scale here, A, and it has only centimeter markings and no 1/10 or 1/100th. If I look at this line and have to guess, the only thing I can do is it is 1 centimeter. I can say it is 1 centimeter. So this has one significant figure. Let's see another example. Let us say this one. Let us take this one. So somebody reported this as 1 centimeter. Somebody who doesn't know this scale, and let us say another student, instead of reporting it as 1 centimeter, has reported it as 10 millimeters. It is correct. 1 centimeter, and another student has given it as 0.01 meters. Now we don't know, somebody who doesn't know what scale was used and only looking at these measurements And if you have to come up with the significant figures, this seems to say it is one significant figure, and this one, is it 2, is it 3? So there is some confusion here. So what scientists did is, here there is unit conversion, so because of which the number of digits have increased. When we are looking at numbers, was there a unit conversion, or was it an exactly a millimeter scale was used or a meter scale was used where 1/100th of a meter has been marked? We don't know. So when there is ambiguity there, what scientists said is, any number which does not have any decimals, for example this one, it doesn't have any decimals, so we are doubtful, we don't know whether this zero was because it was a millimeter scale or not. So in that case, they said any number without any decimals, all the trailing zeros will be ignored. So they said no trailing zeros, so ignore this zero and we have only one significant figure. Similarly, in this case, they said if the number is less than 1, which is, or it is starting with 0 point something, all the zeros until you hit that a non-zero number, these are all not significant. So even here we have one significant number. All trailing zeros when there is no decimal will be ignored. All the zeros before a non-zero when there is a decimal and it is less than 1, all these will be ignored. So these two will be ignored. So those are the two rules. The rest of the rules, there are 3 more rules. One is any non-zero number is significant. 4, 5, 6.23. These are all non-zero. So these are all significant. So we have 1, 2, 3, 4, 5 significant figures. Any zeros in between, they are significant. 1, 2, 3, 4, 5. 5 significant figures. 4,000. Now we have only one significant figure because trailing zeros are ignored. 0.001, one significant figures. All these are ignored. But 1.00, now this cannot be ignored, because somebody, when they wrote like this, it means they were precise, that they had a scale and that they were able to go up to 1.00. So this cannot be ignored. So this has 3 significant figures. These are easy to remember, but this and this, there is some confusion. So to remove this confusion, scientists have come up with a scientific notation of reporting numbers. So any number should be reported as, in the form of, it should be reported in the form of a into 10 to the power of b, where a is less than 10. A is a number that is less than 10 or greater than or equal to 0, and b is any integer. B is any integer. So this way there is no more confusion. That's the idea. This is called the scientific notation. So now let us see, how do we represent each of these in the form of a into 10 to the power of b. So this can be written as, it should be a number less than 10. So this is 456. So this should be written as 4.5623 into 10 to the power of 2. So a into 10 to the power of b. So this is clearly, we don't lose the number of significant figures. Here we have 1, 2, 3, 4, 5. Here we have 1, 2, 3, 4, 5. Similarly here, this can be written as 4.0523 into 10 to the power of 2. This one here, This is 4 into 10 to the power of 3. So one significant figure. This one is 1 into 10 to the power of minus 3. Again, one significant figure. And this is 1.00 into 10 to the power of 0 or 1. So here we have, because there is a decimal, we have 1, 2, 3 significant figures. That's all for today. We'll meet in the next class.